Hello everybody again, thanks for the kind introduction. The topic of my talk today is about technology and how we can use that to understand human mobilities, in particular in cities. First of all, for transportation planning, we need to learn a lot about how people use transportation, and we need a very deep understanding on the mobility behavior of different people. So the questions that we're asking ourselves is, how is the traffic motivated, or how is the infrastructure used in order to, of course, improve infrastructure designs? And also a very valid question is that there are different user groups, so we need to understand what are the needs of the different user groups related to mobility. And in particular, we would be interested in know the traffic demand to model that. So we can think about a picture like it's showing here. We want to know the mobility patterns. So where do people live, and what path do they use for work, at what time are they working, how much time do they spend there, and then again, what other trips are they producing in terms of shopping or recreation, and at what times that occurs. So this is what we want to know about the mobility behavior of people in a city, sort of origin and destination relationships in transportation modes. And we want to know what kind of transportation modes they use. So the question is how to get there. One solution for that is like very traditional wise census data. So this is an example of the census of population of Ireland. So there are different questions that people are getting asked about the usual trips and what kind of mode of transportation they use. And then from that you can get from a defined sample some answers how people move, and you can derive some commuting patterns out of this. But it's very intensive in terms of questioning people. Also, it's a question of data quality. So people report their trips, but what kind of quality is then in the data? Do people report it very detailed or just very coarse? But this is something which is, of course, applied. Technology is not available in all cities, but this is something you can apply in a wide range of cities. But as data becomes more available, of course, we know that at least from ourselves. We have our cell phones, so we all over the world create data using our devices. There is this name of Internet of Things. So data is produced in a huge amount. We also call that big data, what's a term that is used very widely in the last years. And this kind of data and communication that we use can also reveal certain mobility patterns about people living in a city. So the question is how to use that data, but before we get to technologies that are very sophisticated, we also need to understand that in some cities those data sources might not be available. So there is still traditional methods in use, like manual counting, but as you can understand from manual counting of traffic volumes is very interesting. It gives you very good information about volume trends, for instance, but it's also very limited in terms of length of the sampling period, because it has to be done manually, and it's of course cumbersome, and there is a high likelihood to include lots of errors in this method. More advanced technology for counting and even tracking individuals, like people walking in open space, as we did here in a project together with MIT in Berlin, or you can also track cars, bicycles, and even classify those different users, is using video information and then image processing technologies to automatically detect those subjects in the video. And you can even combine that with other data sources. In this example, we combined it with environmental sensor data, like the noise or some pollution information. And you could also link that to social media traces related to Facebook and Twitter, and learn more about activities that people are engaged in this area. Another source of data or technology is coming from also non-invasive sensors like Bluetooth and Wi-Fi. This has been used in the past for tracking, in particular, people movement, like pedestrians walking around in certain infrastructures, also transportation infrastructures or airports. But you can also use that, as you see here, in a more long-range way, so long-range detecting of devices that are Bluetooth or Wi-Fi enabled to track the paths of car users. So you can get the sequential movements of cars as they move in a city or on the highway, and you can also reveal very interesting movement patterns from that kind of data set. Of course, the sample is limited, so you only can detect people that have those devices enabled, but still from the small amount of people, you can extrapolate to a whole population and get very interesting results from that. Another technology that is also in use already is counting sensors. So public transit vehicles like buses or trains in metro systems are getting more equipped with these automatic counting sensors. They are, for instance, installed at the doors, so they count the flow of people boarding and alighting a train, for instance. And there is also this transit smart cards, which are in different countries available, like the Oyster card in London, but also there is a system in Seoul called T-Money, and they are becoming more popular in all over the world. And this collects very interesting data sets in terms of we get the usage of people for an individual mode of transport, but we get also the very complex paths, which are sometimes very complex, of people using different modes in different order for the trips. Another interesting technology is the mobile phone data. So you can also use those kind of data set that is produced from just moving around our mobile phones, and it's actually created on the side of the provider. So they know in which cell a certain mobile phone is currently located. And if you get access to that data, which is somehow possible, but not very easily possible in some situations, because there is legal issues, there is the issue of how to anonymize this data set, to work around with that, to get rid of this legal issues. But still, in the field of research, there is already lots of work done to use mobile phone data, those so-called call detail records, to derive traffic demand from this data set. And what you get here is you get large data samples. If in a city lots of mobile phones are in use, people have one or multiple phones, so you can get lots of data, and you can export the results also to simulation tools like one from PTV, for instance. That's what we did at the AIT, to include the traffic demand directly into the traffic simulation. An example that you can see here is this video is from the city of Vienna, where you can see here is the city center, and in the morning the movement pattern of just from the mobile phone data is that people would travel in that direction, while at later times of the day people would again move to the outskirts. So this is some very interesting patterns where you can see that different parts of the cities are frequented in a different way and used in a different way, and how to address that in planning a transportation system. So we also verified that kind of mobile phone data using the traditional data that we get from mobility service, and it turned out that we can derive the same patterns from the traditional data, the data collection, which we can also derive from the mobile phone data in a more efficient way. And of course, this was an example from Vienna, but we have also other examples in other cities, like in Dhaka or in Rio de Janeiro or in Beijing, where this kind of data is already in use. To go a little bit more advanced in terms of data collection is something that we would call Smart Survey, which is basically distributed as a very simple app on your mobile phone that gets access to different kinds of phone-related sensors, for instance, GPS or accelerometer. And what this kind of app does, it automatically collects this data, and it extracts the trips, which can be recorded from the GPS data, but it can also detect transport modes. So by this very rich data sets, we can detect, is this person right now using a car? Is this person walking? Is he using a bike? And so on. And you can deploy it via the official app stores, so it would be available very easily for people. And it's also, there is a possibility to include customizable questions, so you get tracking of the mobility pattern and a survey at the same time. And it can be collected and analyzed on a web app. So in the browser, you can already see during the data collection, so what is the mobility patterns that I can see there. I can also, if I find something interesting in the data, I can adapt the survey and go into a more deep analysis of that. And we, of course, have to deal with privacy and legal issues, but this is also addressed to make sure that there are some security concepts so that data and the identity of person is strictly separated. Yeah, this is a little bit dark, but just to illustrate you, we can then extract different means of transport. So we have here buses, walking, biking, car, and this is public transit. And we can now extract up to 8 different means of transport, very reliable, using this kind of data sets. Another possibility to work with the GPS tracking data is the way to track informal traffic. I guess you're all aware about informal traffic that is not created like from a centralized unit that plans certain routes for transportation. There is this, of course, a famous example from the city of Manila with the jeepneys, and there is also an example in Nairobi where they tracked the informal traffic and even created a map of how this mode of transportation is used. So we talked a lot about technologies and how they can help us to understand mobility patterns in cities. But of course, we need to reflect that very critically. There are some limitations depending on where to apply that, of course. And in terms of video, we have to see that there is, of course, a limitation when you apply it in different cities. You have to be aware that there needs some kind of security. So theft of the equipment might be an issue. There is weather issues. So if there is very bad weather conditions, even snow or heavy rain, then this could influence the tracking precision. And we also need, of course, it's mounted infrastructure. You need some kind of power supply and so on. But of course, you can, or how it's usually done right now. If you want to address those issues in a different way, you can just temporarily install these cameras, record some video footage, and do the analysis, the annotation of where people or where cars are in a manual way afterwards. For Bluetooth and Wi-Fi, as I said before, it requires some technologies. So smartphones need to be available and they need to be equipped with those kind of communication technologies. And those technologies also have to be enabled on the phone. And what we can see is that, of course, in developing countries, having a smartphone is still not like the common case. But also here, the penetration rate of phones and then to smartphones is increasing as they become more affordable. So this might be a trend for future to look into that as well. For the automatic counting and transit smart card, so we can see there are already some examples that this is in use in bus rapid transport system and the metro lines, as I showed before. For the mobile phone data, there is some issues on mobile phone that we have with the data availability. I've heard there was also a study at ADB on the prepaid contracts that this data or this kind of data might not be available like for regular contracts. And there is, of course, as I said before, some legal issues that has to be addressed. So it's not very easy to get access to this kind of data for, of course, certain reasons. And there is some unclear revenue model also for the data provider in that sense. There are some initiatives, like from the Gates Foundation, to fund servers to store those kind of mobile phone data, which is happening now in Brazil. And cities are working on a legal framework also to address these legal issues, like in Vietnam and Philippines. And there is also a working group of the World Economic Forum, which is led by Sandy Pentland from MIT, working on these issues. For the smart survey, so the application that I showed with the app on the phone and collecting all the different kinds of sensor data from GPS and accelerometer and so on, it's the same issue as I said before. So we need, of course, some penetration for smartphones to use that kind of technology for extracting mobility behavior. But we also see, again, this is increasing slowly, but it is, and also the cost of data is an issue, but also this is improving over time. But still, if we want to go into that direction right now, there might be another solution to go into a consultancy model, which could be based on giving away only a small amount of smartphones to a small number of people, and which could be done in cooperation with local service staff, and then we still can use this kind of technology to collect data. So, in summary, we can see from our research that we're doing at AIT together with MIT and from different examples all over the world, that technologies in cities, if they are applied in the right way, can get more information or a more accurate overall picture, but they can also give you the chance to look very deep into the details of individual journeys. And we can understand the load profile. So one example is how crowded is a particular bus at a certain time. And we can use that for planning our cities, our different modes of transportation, and also very complex multimodal transportation systems. It can also be used, this kind of data, to improve our designs of infrastructures for walking, but also reduce congestions on the streets. And we can also think about how to integrate those kind of mobility data into other services such as retail. So, this was a very quick summary about technologies and mobility in the cities, and I'm happy to answer your questions later on.